Hello and welcome to Empowered Learning. This video will be about evaluating square root expressions. So when we talk about a square root, we're actually talking about a number that is one or two identical factors of a number. And so what we mean by that is this, putting it in another way. What number can we multiply times itself 2 times in order to get the number that is under the radical? So like how we see here, we know that for 144, we know that 12 is the number that we will multiply times itself twice in order to get 144. Now, another thing that we need to understand is some of the language here. Now, of course, this is a radical sign, and what is under the radical is the expression called the radicand, okay? And of course, the number that we have here, that's called the square root in this case, okay? And so we cannot take the square root of a negative number because that doesn't really make sense. To show you why that is, I'm going to actually draw you a graph of what square root of x looks like. And then from there, explain to you why we cannot take the square root of a negative number. Also, why when we answer questions like this, like square root of 144, if we are talking about what's called the principal root, we only answer it with a non-negative answer. Because some people think that this is plus or minus 12, and that is not necessarily true. And so I'm going to draw a graph here and explain all of that. Okay, so the basic graph of square root of x looks something like this. So I'm going to draw my x and y axes, and then it kind of looks like a steering wheel. So this is what square root of x looks like graphically. If you notice here, notice that the smallest x value that we have that we can plug into this particular function is 0. If you notice, nothing else is on the left side of the x-axis, or in quadrants 2 and 3. So because of that, if we were trying to, let's say, plug in negative 144 into the square root here, do you notice that that would ideally be something that's like way over here? So let's say this is negative 144. Since we don't have, the graph doesn't exist over here, then that means we can't evaluate it. For those of you that are familiar with complex numbers, the answer to this would be 12i. And of course, you can watch my videos on complex numbers to sort of get a sense for that. But it's kind of out of the scope of what we're doing here. But again, the main reason is this is what the graph of square root of x is. And the answers that we get are what we call principal roots. So for instance, let's say I wanted to do square root of 4. What that looks like graphically is like this. So if this is when x is 4, then it corresponds to this particular point, and we can map that to here, which is going to be a value of 2. Notice we can't say that this is plus or, let me do that again, plus or minus 2, because if we were saying that it was minus 2, then we would have to have the graph actually come down here and look like this. And if you notice, that graph doesn't do that. The reason why we can't draw this graph down here is because if we draw it, then the graph that we see with it kind of turning like this isn't a function because it doesn't pass the vertical line test. Okay, so that's just some background knowledge for you there. So in short, we know that whenever we're drawing the square root function, that it has to be this function that goes up like this, and we only have one answer to it. Now, to clear up why some people think that square root of 4 is plus or minus 2, That happens because when you solve equations like this. And when you solve equations like that, how you solve it is you take the principal root of x, which looks like this. And then that answer is plus or minus 2. The reason why that is because of how the graph of what x squared looks like. And so if I draw that for you quickly, x squared just looks like a function that looks like a u. And of course, what you're asking here when you solve that equation is give me the corresponding x values for the graph of the function x squared, which is what we have here, that has a y coordinate of 4. If you notice, here we'll have 2 points. We'll have this point, and we'll have this point that have y coordinates of 4. And if we map those down, we'll see that the corresponding x value here is a -2, corresponding x value there is a +2. So we have these 2 points. Let me erase that and start over. We have these 2 points, -2, 4, and we have +2, 4. And so when we're solving these equations, when we take the principal root, we have to write it this way, knowing that we take the square root, but then this plus or minus part is recognizing that from this graph, we know that we're going to have an answer that's on the left side of the x-axis and an answer that's on the right side of the x-axis. So that is why some people think that square root of 4 is plus or minus 2. But it's actually just 2 because of what this graph is. The plus or minus part comes from solving these types of equations here, which map to these kind of graphs. Okay. So I'm hoping that that clears that concept up a bit. So now let's go and evaluate some of these. So we know that square root of 4 is just 2. We know that square root of 9 is just 3 because 3 times 3 is 9. We know that square root of 100 is just 10, but since we have this negative that's out here, then this negative is understood to be a -1 times whatever square root of 100 is, which is 10. And we know square root of 100 is 10 because 10 times 10 is 100. Similarly, we know that 8 times 8 is 64, so the square root of 64 is just 8. And I'm going to move over here and then go down. So we know that for 169, 13 times 13 is 169. So the square root of 169 is 13. The square root of 625 is 25 because 25 times 25 is 625. The square root of 0 is just 0 because 0 times 0 is 0. All right, so moving on here. You see that, for example, E, notice that we're trying to take the square root of a negative number, and that does not yield to us a real number as a result. For those of you that are familiar with complex numbers, this number would actually end up being 6i, okay? But again, that's out of the scope of what we're trying to teach here. So for F, negative square root of 81, we know that 9 times 9 is 81, so the square root of 81 is just 9. And of course, this negative here is understood to be a -1 times 9, and that's how we get -9 for an answer. For here, this one is not real, because again, if I were doing this, I know I cannot take the square root of a negative number. If I were doing complex numbers, then I know that this would be, just this part here would be 9i, and then of course I would append the negative there. And the reason why I'm saying I is because of what we see here. The definition of I is square root of -1. So even though this is not a real number, then what this actually means in definition when we talk about complex numbers, that is I. And to kind of give you an example here, when we do negative square root of negative 81, we can actually rewrite this way. And of course, this part is where the I comes in, that part is where the 9 comes in. And if we multiply those, we have 9I. And of course, if we appended a negative here, then that will end up being a negative 9I. So that's what it would actually be if we were allowed to answer in complex numbers. But since we're not, then we're just saying that these answers here aren't real numbers. All right, going back to H, we know that 4 times 4 is 16, so the square root of 16 is 4. We know that 1 times 1 is 1, so the square root of 1 is 1. And here again, we see that our negative is on the outside, so we'll just put that there. And we know that square root of 25 is just 5, because 5 times 5 is 25. And so our answer here is a negative 5. And similarly, we know that square root of 49 is 7, because 7 times 7 is 49. And of course, our last one on this page is square root of 121. And we know that 11 times 11 is 121. So square root of 121 is 11. And so this concludes the video on evaluating square root expressions. Thanks for checking this out. Take care.